So the last thing we need to learn about in quadratics is the quadratic formula. This whole page is here because I'm going to derive the formula for you. You will not be tested on this. You will not have to reproduce it. And if you look at it at the end of it and you go, nah, didn't like it, that's okay. But it is a very interesting derivation because we use completing the square that we've been learning about to make the formula that we're going to be using. So, as we know, the quadratic, the general form of a quadratic is this here. ax squared plus bx plus c equals 0. Now, if I'm going to use completing the square on this formula, first of all, I do not want a number in front of that x squared. I'm going to rewrite it. Here is my starting equation, ax squared plus bx plus c equals 0. To get rid of that a out the front, I'm going to divide the whole equation through by a. So a divided by a means there'll just be an x squared for that first term. For the second term, I'll have to divide the b by a, and the c I will also have to divide by a. Technically, you need to divide the 0 by a as well, but 0 divided by anything is still 0. Okay, so you divide every single term by a. Now it is a monic quadratic. So now I can complete the square. The process for completing the square is to take the first two terms, the x squared plus the b over ax. Now this is the fun part. We take the coefficient of the x, and to complete the square, we always want to halve that. To halve it, I just need to divide an extra 2 on the bottom, because you're dividing by 2, so that the 2 appears on the bottom of that fraction, and I need to square that. Okay? So that would make b squared on the top, and squaring the bottom would be a 4 and an a squared. You have to square everything. You square the b, you square the 2, and you square the a. Everything gets squared. To complete the square, we have to also straight away take that away again. And we have our plus c over a sitting on the end. Okay, equals 0. The first 3 terms will now factorize to be a perfect square. That means the x will be at the front of the bracket, and the b over a that is circled there in red, remember we always halve that number, and that's the number that goes into our bracket. So half of that, we've done this already, is b over 2a squared. Okay, now these 2 parts on the end, they are some terms, some numbers, they would be numbers that I want to collect up. It would be great if I could get a common denominator. So the common denominator would need to be a 4a squared. Okay, the first one already has the 4a squared, the other one has the a, it just needs an extra a and a 4 as well to get a common denominator. So let's go minus b over 4a squared. I'm just going to get a common denominator with that second one first. So that would be 4a squared on the bottom, timesing a 4 and an a to the top with the c that was already there.
Isn't it b squared?
The a squared?
No.
Oh, that one. Sorry, yes, you're right. I forgot my squared, the first one. I just didn't copy that one down right. Correct. Okay, so now let's push those 2 fractions together. Actually, before I do that, let's move them to the other side. Because remember, when we do completing the square, we now want to get that x by itself. So that's going to be x plus b over 2a all squared. When I move the minus b squared over 4a squared across, that whole term will just become positive. B squared over 4a squared. And the last term, move it across and it will become negative. Okay, and I probably could have combined that in one step, but I'll do it in an extra step now. Combining those two terms that I've already made a common denominator, I have a b squared minus 4ac, and then I have a 4a squared as my common denominator on the bottom. Still following along okay? All right, cool. So like we usually do, I'm trying to get this x by itself. So the next step is to square root to get rid of that squared there. Unfortunately, I cannot square root the top of the fraction on the right-hand side. It doesn't square it very nicely. So I have to put a big square root sign over the b squared minus 4ac. However, the bottom of this fraction, the 4a squared, that does square it nicely. You can square root the 4 and it gets a 2, and the square root of a squared is just a. All right, one last little bit to do. I have this b over 2a to get by itself. So I'm going to subtract it to the other side. So x equals, oh, one thing, whoops, when I square root, what else do I need? Plus or minus. Nearly forgot it. There it is. Plus or minus in front of that square root sign. So I have plus or minus big square root b squared minus 4ac all over 2a. And then I'm going to subtract the b over 2a from the other side. I'm moving it across. Conveniently, I have a common denominator there. Can you see that? They're both 2a's on the bottom. So I'm going to push those two fractions together, and the formula that you will be getting used to seeing has that b, that minus b comes first. I'm going to switch the order. So I'm going to put the minus b out the front. Then we have the plus or minus big square root of b squared minus 4ac all over 2a. And that is what you will now forever know as the quadratic formula. It means instead of having to use completing the square or factorize or anything else, if you know what the a, the b, and the c are in your quadratic formula, the a, the b, and the c are just the numbers that are in front of these terms here. You just read them off your equation that you've been given, and you can substitute them into the formula to get your solutions. This doesn't work for factorizing, okay? It has to be an equation. It's for solving quadratics, okay? Lily?
If it doesn't have an a, we just so it'll be...
Are you doing the examples already?
No, I'm curious.
If there's no number in front of the x squared, is that what you mean? It'd be a 1.
Yeah, then
It'd be a 1.
drop the a.
No, it'd be a 1.
Okay.
Yeah, if there's no number there. But we'll do that when we get to the questions. All right, so it's written here nicely for you. There it is. X equals minus b plus or minus square root of b squared minus 4ac over 2a. That will be your new favourite little thing to say. Yeah, Emma?
You guys want me to do a test?
Yes, this is on the test.
Okay.
Yep.
Like this?
This formula, you need... No, you don't have to derive the formula. You meant they have to know how to use the formula. Yes. Sorry, no, I was answering her question. That was a yes to her. Do you get the formula?
So was the first page...
Oh, I have to check that. I'll have to check that. I'll have a look. Okay.
Miss, was the first page deriving it?
I thought you were saying that.
All right, you 10, settle down, please. You do not have to be able to derive the formula, okay? That was just for fun, okay? You have to be able to use the formula. And here we go, we're going to use the formula. So question number 1, use the quadratic formula to solve this equation. 3x squared plus 4x plus 1 equals 0. So the first thing you want to do, because we're new to this, you want to identify the a, the b, and the c. So as long as your quadratic is in order, so x squared term, x term, constant term, a is what's in front of the x squared, b is what's in front of the x, and the c is the constant number on the end. Now it's going to be good for you to write the formula down first, so let's write it. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. So we're literally subbing those numbers into that formula. So minus b is the first part. B, for my equation here, is 4. So it's going to be negative 4 plus or minus. Big square root sign. then the b squared, so b is still 4, so it's going to be 4 squared minus 4 times a, which is 3, and c, which is 1, all over 2 times a, and a is 3. Is that okay, everyone? We're just subbing those numbers in. Now, depending on what the question asks you to do, sometimes the questions will ask for decimal places, like this one down here. Sometimes the questions will specifically ask you to leave your answers exactly. Okay, so I'm going to proceed with this one in an exact form for a little while. The first thing you would do is to work out what is underneath that square root sign. So you can type it into your calculator. If you get your calculator out, just the 4 squared minus 4 times 3 times 1. Okay, equal to 4. Okay, that's nice. So I have minus 4 plus or minus square root of 4 over 2 times 3 is 6. Now this actually turns out to be a very nice quadratic because that number under that square root sign actually square roots very nicely. It won't always happen, trust me. But this one's going to go nicely. Square root of 4 is 2. So I have minus 4 plus or minus 2 over 6. Now remember that plus or minus is how you get your two solutions. We usually expect two solutions, but not always, but usually. To get your final answers from there, we are going to type the fraction in twice. The first time, here's my fraction button, I'm going to type in minus 4 plus 2 over 6. Minus 4 plus 2 over 6. So that gives me my first solution, which is a third. The second time, it's the same fraction, but I want to do minus 4 and changing that to a minus 2 over 6, which equals negative 1. Okay, so they are the two solutions for x. No factorising, no completing the square, just using the quadratic formula. Keisha? Ah, yes, thank you. Missing minus signs today. All right, question 2, let's try it again. Use the quadratic formula, this time to 2 decimal places. So the a, the b, and the c. A is 3, b is negative 12, and c is negative 3. So the formula, write it down. It's going to help you familiarise yourself with it, and hopefully, even if you do end up getting it, it is a really good one to know off the top of your head. Minus b, plus or minus big square root, b squared minus 4ac over 2a. So then we want to substitute in. So b this time is minus 12. If I have a minus in my formula and b is minus 12, it's going to make it positive. So positive 12 plus or minus big square root. The b squared, b is negative 12. Whenever you're putting a negative number in for b, please put it in brackets when you're squaring it. That's a very common mistake. People forget to square their negative and then it messes up your whole square root sign. Okay, so negative 12 in brackets squared, minus 4 times a, which is 3, times c, which is minus 3, all over 2 times a, and a is 3. So like we did last time, let's work out what is underneath that square root sign. So I have brackets, negative 12, close brackets squared, minus 4 times 3 times minus 3. Okay, 180. 12 plus or minus square root of 180 over 6. 180 is not a number that is going to square root nicely. If I had to do this question exactly, like I was doing the last one, you will at times have to simplify surds to get a nice simplified answer. Okay, so be prepared for that. But this one did ask me to go to decimals, so I'm not going to do that here. If it asks for decimal places, you can go to your calculator now with your fraction button, and we're going to do 12 plus the square root of 180 all over 6. my first solution to two decimal places will be 4.23. Okay, then for the second solution, you need to go, just change your plus to a minus sign. So it's, delete that minus sign, and it is negative 0.24. Okay, that's it. That's how you use the quadratic formula. The problem is, in this topic, we have now looked at quite a few different techniques that we can use to solve quadratic equations. The fastest method should be, if you're confident, should be to factorize. But not everything can be factorized. And we know that, which is why we had to look at some other methods. Then we had completing the square, which was useful, but even completing the square doesn't work nicely for everything, which is why we have the quadratic formula. There are still some equations that can never be solved with the techniques that we have. Some quadratic equations do not have any solutions. So how are we going to know what technique to use and how many solutions we're expecting to get from a quadratic equation? And that is this next part of work here. If we look at our quadratic equation, our formula that we've just been given, minus b plus or minus square root of b squared minus 4ac over 2a. What is happening with that square root? The b squared minus 4ac, this part under here, what happens in there tells you how many solutions you're going to get to your quadratic formula. So we give that a very special name. This b squared minus 4ac, we call that the discriminant. Don't know why they called it that, but anyway, it's called the discriminant. The symbol for discriminant is the triangle. It's a Greek letter. It's not actually a triangle. It's a Greek letter, but it is equal to b squared minus 4ac. If we're wanting to do a quick check with our quadratic that we've been given to solve, if we're trying to find out how many solutions we're going to have, we sub in our a and our b and our c into this, and the number that we get tells us the number of solutions. If I get a number that is less than 0 is another way of saying negative, right? If I get a number that is negative, it means that I'm trying to square root a negative number. Is it possible to square root a negative number? No. So as soon as you get a negative through discriminant, that means that that quadratic equation has no solutions. It cannot be solved in any of the methods that we've been given. Cannot solve it. There is 0 answers, no solutions. Okay? If we get a number that is equal to 0, that means I'm square rooting 0, which is just 0. And if I'm adding and subtracting 0, am I actually taking anything or adding anything on? It's 0. This whole part here is 0, which means the plus or minus is actually doing nothing. And the only answer that I'm going to get is going to come from this minus b over 2a, which means it's only going to be one solution because the plus or minus has been taken out of the equation. Yeah, you see where I'm going with this? So less than 0, no solutions, equal to 0, one solution. If you get a number that is greater than 0, that's the type that we're used to. That means that we're going to have the plus or minus in there of a number, and we're going to get our normal 2 solutions. Okay, so the last thing we have to practice on the next page. It says, determine the number of solutions to the following quadratic equations using the discriminant. I'm not actually asking you to solve them. We just want to use the discriminant so we can practice finding how many solutions it would have. Okay, so the discriminant is triangle for the symbol. Discriminant equals b squared minus 4ac. A is a 1, that would be in front of that x squared. B is the 6, C is the 2. Subbing those in, b squared would be 6 squared minus 4 times a, which is 1, times c, which is 2. And that equals? You want me to tell you, don't you? 28. Okay. It equals 28. Okay, the number itself is not important. The only thing that's important here is if it's negative, 0, or positive. Okay, 28, that's a positive number. It's greater than 0. That means how many solutions? Do you remember? 2. Okay, so we write therefore 2 solutions. Okay, that's all you're going to have to do for now. A little bit more on top of that though, for those of you who like a little bit of extra clarity on what that means. If the number that you get here, 28, if it square roots nicely, it means that you could probably factorize that quadratic equation because you're going to get nice numbers because it's going to square root nicely. Because 28 does not square root nicely, it means that you're not going to have nice solutions, so it's either going to be completing the square or the quadratic formula. Okay? But that's a bit of an extra. Let's do it again for B. Let's find our discriminant. So formula, discriminant equals B squared minus 4AC. A is equal to 3, B is equal to -5, and C is equal to the 4. Sub them in. Remember, if you're subbing in a negative number for B, put it in brackets. -5 squared minus 4 times A, which is 3, times C, which is 4, equals -23. Good. Okay. As soon as it is negative, which is less than 0, I go, can't square root that. So that means that there are no solutions. No matter how hard I try, factorizing, completing the square, quadratic formula, none of them will solve that equation for me. And last one, discriminant equals B squared minus 4AC. A is equal to -2, B is equal to 3, and C is equal to -7. Subbing in. 3 squared minus 4 times A, which is -2, times C, which is -7, equals -47. So negative again, a little bit boring, would have been nice to have a 0 in there, wouldn't it? Negative again, which means no solutions again. And just remember, we didn't have one, but if it was to equal 0, it would be one solution. Yes.
Are we going to get that formula on the test?
You wouldn't get the discriminant one, but it comes straight out. If we do, I'll have to check with Mr. It's not on the test. I'll have to check with him as to whether we're going to give you that as an extra. It is one that is on the NESA study sheet for year 11 and 12, so it's definitely a possibility that we will